video is brought to you by Exams A to Z+.
Hello everyone. Before we go to exercise 2.4, which is optional, we'll learn some things here. So let's say if it is a cubic equation, generally we can write the cubic polynomial a cube, ax cube plus bx square plus cx plus d. This is a cubic polynomial. And if I say zeros of this polynomial are alpha, comma, beta, comma, gamma, then I can write it as a minus alpha into x minus alpha, x minus beta, x minus gamma is equals to 0. Multiply it first, x square minus x beta minus x alpha plus alpha beta into x minus gamma is equals to 0. Now x cube minus x into this one is minus x square beta, then after minus x square alpha, then after alpha beta into x, then after minus gamma x square, then multiply this plus gamma into beta x plus alpha gamma x, finally minus alpha beta gamma, which is equals to 0. Now if I take the polynomial, it looks like, take first x cube, common minus x square. So if I common x square, it will be alpha plus beta plus gamma, then after plus alpha beta plus beta gamma plus gamma alpha into x, finally minus alpha beta gamma is equals to 0. Now you have to compare ax square plus ax cube plus bx square is equals to 0 divided by a, then it will be x cube plus b by a x square plus c by a, this is d by a is equals to 0. Compare it with the cubic equation that we got, minus alpha plus beta plus gamma plus alpha beta plus beta gamma plus gamma alpha, finally minus alpha beta gamma, which is equals to 0. If you compare these two equations, you will get alpha plus beta plus gamma, that is sum of roots or sum of zeros, is minus b by a. Then after sum of product of roots, alpha beta plus beta gamma plus gamma alpha, this is plus c by a. Finally product of zeros, that is minus d by a. So this is a basic that we need to know before we solve the cubic one. Sum of roots is minus b by a. Sum of product of roots, this is sum of product. So you say this is sum of roots. Sum of product of roots is c by a. Product of roots or product of zeros is minus d by a. Zeros or roots, both of them are same. So sum of zeros minus b by a. Sum of product of zeros is c by a, and then product of zeros is minus d by a. Now we'll move on to the question. Look at the first one. It says verify the numbers given alongside of the cubic polynomials below are their zeros. Also verify the relationship between the zeros and the coefficient in each case. First of all, we'll try to verify whether it is 0 or not. So all you need to do is just take the given numbers and substitute in the equation. If I substitute 1 by 2 in the equation, 2 into 1 by 2 whole cube is 1 by 8 plus 1 by 4 minus 5 into 1 by 2 is 5 by 2 plus 2. So this is 1 by 4. 1 by 4 plus 1 by 4 is 1 by 2 minus 5 by 2 plus 2. This is minus 4 by 2 plus 2 becomes 0 here. So therefore 1 by 2 is a 0. Now look at the second one. If I substitute 1 here, 2 into 1 cube plus 1 square minus 5 into 1 plus 2. 2 plus 1 minus 5 plus 2, that is 0. Therefore 1 becomes 0. Now substitute minus 2. 2 into minus 2 cube is minus 8 plus 2 square is 4 minus 5 into minus 2 plus 2. This is minus 16 plus 4 plus 10 plus 2 minus 16 plus 16 becomes 0. Therefore these three are zeros of the given polynomial. Now we'll try to verify their relation. From the given polynomial, first write down the values. A is 2, B is 1, C is minus 5, D is 2. First, sum of zeros, that is 1 by 2 plus 1 minus 2. This is 1 by 2 minus 1, which is minus 1 by 2. But this actually minus b by a. So I can say minus b by a is minus 1 by 2. So first one, we have verified it. Now look at the second. Sum of product, which is alpha beta, beta gamma, gamma alpha, which is equals to actually c by a. So alpha beta is 1 by 2 into 1 plus 1 into minus 2, then after plus minus 2 into 1 by 2. You get 1 by 2 here, minus 2, minus 1. So 1 by 2 minus 3 gives you minus 5 by 2. So c by a here is minus 5 by 2. Finally, we need to check the product. Write down the product as 1 by 2 into 1 into minus 2, that is minus 1. So product is d by a minus d by a, that is minus 2 by 2, that is minus 1. So the relationship is also verified. Now look at the second one. First substitute 2. If I substitute 2 here, 2 cube is 8 minus 4 into 2 square is 4 plus 5 into 2 minus 2, which is equals to 8 minus 16 plus 10 minus 2. 18 minus 18 gives you 0. Now when you substitute, this is 2. When you substitute 1, 1 cube is 1, 4 into 1, 5 into 1 minus 2. So I can say 6 minus 6, which is 0 again. Now all I need to do is verify the relationship between the zeros and sum and product and all that. We know sum of roots, that is 2 plus 1. First of all, we'll write a, b, c. Here a is equals to 1, b is equals to minus 4, c is equals to 5, d is equals to minus 2. Sum of roots 2 plus 1 plus 1 is 4, that is minus b by a, minus of minus 4 by 1. So 4 is equals to 4, it is verified. Look at the second relation. Sum of product of roots 2 into 1 plus 1 into 1 plus again 1 into 2, which is equals to 5. 2 plus 1 plus 2. C by A. C by A is 5 by 1. Absolutely correct. Now look at the next one. That is product. Product of roots alpha, beta, gamma. That is 2 into 1 into 1 is equals to minus d by a. Minus d by a is minus of minus 2 by 1, that is 2. So 2 is equals to 2. So the third relationship is also verified. Now look at the next bit, second question. Find a cubic polynomial with the sum of products of its zeros taken at the time and the product of its zeros as 2 minus 7 minus 14 respectively. Now look at here. We know the polynomial is ax cube plus bx square cx plus d, where the relation between this alpha plus beta plus gamma sum of zeros is b by a, alpha beta plus beta gamma minus b by a, it is plus gamma alpha c by a. Then after product is minus d by a. Write down the values given. So if I write the values, it is 2 minus 7 minus 14. Anyway 1 1 1 you write. Therefore a becomes 1, b becomes minus 2, c becomes minus 7, d is 14. So just write down. The polynomial is a value is 1, so therefore x cube, b value is minus 2, 2x square, c value is minus 7, 7x, d value is 14 plus 14. This is the required polynomial. Let's move on to the next one. If the zeros of the polynomial given is a minus b, a plus b, find a and b. Now these a's and b's are different and these a's or b's are different. I can write sum of zeros, that is a minus b plus a plus b. If sum of zeros, if I take it, it is minus b by a. So minus b, which is minus of minus 3 by a is 1. So 3. I can write 3a is equals to 3, which means a is equals to 1 here. In the same manner, product of zeros, a minus b into a to a plus b, that is minus d by a. Minus d by a is minus of minus 1, minus of plus 1, a is 1 here, so it is minus 1. Find the product here, a into a square minus b square, because a plus b into a minus b, which is equals to minus 1. We know the value of a, that's 1. Substitute here. 1 minus b square is equals to minus 1. Therefore you get b square is equals to 1 plus 1, 2. B is equals to plus or minus root of 2. So these are the values of a and b. Don't confuse the values with this a and this b. Here a 1, b minus 3, c is 1, d is 1. This is for polynomial when you compare it with ax cube plus bx square and so on like that. Now look at the next one. If two zeros of the polynomial with a fourth degree given, 2 plus or minus root 3, then find the other two zeros. Because 4 zeros will be there now, so you have to find out the other two zeros. First of all, the two zeros given are 2 plus root 3 and 2 minus root 3. Sum, if you do it, it will be 2 plus root 3 plus 2 minus root 3, that is minus b by a. Product, if you do, 2 plus root 3 into 2 minus root 3, that is c by a. Therefore minus b by a is equals to plus root 3 minus root 3 going to cancel, so you're going to get 4 here. So here c by a is equals to 4 minus 3, 1. If you write by 1 and by 1, a is equals to 1, b is equals to minus 4, c is equals to 1. One factor of this polynomial is x square minus 4x plus 1. You need to divide the given polynomial by x square minus 4x plus 1, and you need to find out the quotient. The quotient will be of the degree 2. It's a quadratic polynomial. You need to find out the zeros of that quadratic polynomial in order to find out the other two zeros there. Now let's divide it with x square minus 4x plus 1. The first term of the quotient, you divide x to the power of 4 by x square, that is x square. So multiply it with x square. X to the power of 4 minus 4x into x square minus 4x cube plus x square. Change the sign. Minus, plus, minus. Write down the values. Cancels. Minus 2x cube 27x square plus 138x. Now, the second term of the quotient, minus 2x cube by x square, you will get minus 2x. Multiply it with minus 2x. X square into minus 2x is minus 2x cube plus minus 4x into minus 2x is plus 8x square minus 2x. Change the sign, plus, minus, plus. You will get minus 36 minus 35x square minus 35. Now, minus 35x square by x square, you will get minus 35. Multiply it, minus 35x square plus 140x minus 35. Everything is going to cancel, so you're left with 0. Now look at the quotient. You got the quotient as x square minus 2x minus 35. X square minus 2x minus 35, find out the factors of it. So you can say it is 35, factorize it, 7 into 5. Minus you are getting, therefore minus 7x plus 5x minus 35 is equals to 0. X common, x minus 7 plus 5 common, x minus 7. So x minus 7 into x plus 5 is equals to 0. And the other two zeros are plus 7 and minus 5. So these are the other two zeros of the polynomial given. Now look at the last question of this exercise. If the given polynomial is divided by another polynomial x square minus 2x plus k, the remainder comes out to be x plus a. Find k and a. If you are dividing, you are getting some remainder. So subtract the remainder from the given polynomial so that this will divide it perfectly. So subtract the remainder from the dividend. X to the power of 4 minus 6x cube plus 16x square minus 26x, because I am subtracting x plus a from the polynomial, plus 10 minus a. Now divide this with x square minus 2x plus k. First, x to the power of 4 divided by x square, you get x square. Multiply x to the power of 4 minus 2x cube kx square. Change the sign, minus, plus, minus. It will be minus 4x cube 16 minus k into x square minus 26x minus 4x cube divided by x square minus 4x. Multiply it with minus 4x. You will be getting minus 4x cube, minus into minus plus, therefore plus 8 into x square minus 4kx. Change the sign, plus, minus, plus. See what you're going to get. 0 here. 16 plus k minus 8 is 8 minus k into x square minus 26 plus 4k. So minus if you common, 26 minus 4k into x plus 10 minus a. Now you have to multiply it with 8 minus k by k into x square by x square. You have to multiply it with 8 minus k plus 8 minus k. So multiply 8 minus k into x square minus 2 into 8 minus k into x plus 8 minus k into k. You are supposed to get the remainder 0 now because we have already subtracted the required remainder. Now, if I am going to get 0, these two must be equal. The coefficients of x must be equal. If I equate the coefficients of x, see here, 26 minus 4k is equals to 16 minus 2k. So therefore 2k is equals to 10. If it comes here, this goes there. K is equals to 5. So value of k is 5. Now another one. Equate 10 minus a, 8 plus k. 10 minus a is equals to 8 minus k into k. Equate them. K is 5. So 10 minus a is equals to, if I substitute 5 here, 3 into 5, 15. Therefore, a is equals to 10 minus 15, that is minus 5. So the value of k is 5 and the value of a is minus 5. That ends our polynomial chapter. Thank you for watching the video. Please share the video and subscribe to the channel examsatozplus for more chapters. Thank you.